All right, so let's go to this one. Works exactly like the one we just did. So I want you to pause the video and try this one and then come back and compare notes. Okay. Okay, you're back. All right, so remember how we set up that other one? Need this little chart. Up here we said time to do job, part done in one, this time we're going to say hour. We have Mrs. Smith, we have the assistant, and then we have together. Okay, so it takes Mrs. Smith 8 hours to do the whole job, which means she gets 1/8 of it done in an hour. Takes the assistant 12 hours, which means the assistant gets 1/12 of it done in an hour. And together we'll call that X, which means 1/X gets done by both of them. And just like in the last problem, that is your equation. So let's solve that equation. I'll do this one a little faster. 1/8 plus 1/12 equals 1/6. The common denominator, the least common denominator is actually 24x. Okay. All right, so on this side, x's cancel. On this side, we are distributing. So we have 24x times 1/8 times 1/12. And then on the right-hand side, we just have a 24. Right? 8 into 24 goes 3. 12 into 24 goes 2. So that gives us 3x plus 2x equals 24, which means 5x equals 24, which means x is 24/5, which is 4 4/5 hours. All right, so again, if you're trying to decide if that answer makes sense, Mrs. Smith can do half the job in 4 hours. The assistant can do half the job in 6 hours. So it makes sense that the answer is between 4 and 6. All right. So our last example for shared work is this one. Now, think about what is the biggest difference between this problem and the two that we did before this. I think the biggest difference is that this time we have the together time. We never had that before. So we have person number 1, person number 2, and together they tell us that person number 1, and the job was proofreading, in case you forgot, takes them 4 hours, which means the part done in 1 hour. Sorry, my handwriting is so bad on the tablet. Is 1/4. Now, when it says with a second person, it takes 2.5 hours. That means together, right? With the second person. So that goes down here. So the part done by both of them working together is 1/2.5. So our X is going to stand for how long would it take the second person working alone. All right, so our equation looks like this. It kind of similar to what we saw in the previous problems, except now the x is in a different place. All right, so we have 1/4 plus 1 over x equals 1 over 2.5. Now that decimal kind of makes things a little weird. What I would recommend as sort of a foolproof strategy when you have decimals involved is just multiply all the denominators together. That's fine. All right, so 2.5 times 4 is 10. 10 times x is 10x. So why don't we just multiply both sides by 10x. All right, so on the right-hand side, 2.5 goes into 10 4 times. And on the left-hand side, we have 10x times 1.4 plus 10x times 1 over x equals 4x. So in the second term, the x's are going to cancel. And you know what I think I'm going to do with the 4 and the 10? Normally I don't do this, but we've already got decimals in here. Why don't we just say 4 goes into 10, 2.5. Normally we don't do that. Feels a little weird doing that, but it's okay. So that's going to give us 2.5x plus 10 equals 4x. So this is a linear equation. So what I would recommend doing is putting the x's on the right side. And that's going to give us 10 equals 1.5x. And now we'll divide by 1.5. All right, and here's something we've never talked about before. How do you change this kind of fraction with a decimal in it into a regular fraction? Because your online homework is probably going to ask for a mixed number. Okay, well, here's what I would do. You can get rid of that 1.5 by multiplying by 10. Hopefully you remember that when you multiply a decimal by 10, it just moves the decimal point one place to the right. So that would give us 100 over 15. And then you can simplify that fraction by dividing out a 5. And that would give you 20 over 3, which is 6 2/3. Okay, so hopefully you know how to do that by now. All right, so if it takes the first person 4 hours working alone, and with another person's help, it takes 2.5 hours, then that means it would take that second person 6 2/3 hours to do the job working alone. So I will leave it to you to think about why that answer makes sense. All right, so finally that brings us to distance problems. Distance problems are the type of word problem in math that everybody makes fun of. A train leaves Philadelphia going west at 9 a.m. Another train leaves Boston going north, whatever. All right. Okay, so to do a distance problem, you need the formula distance equals rate times time. I remember I put this in the review quiz. All right, now, of course, we don't have a beginning algebra course anymore, but back in the old days in chapter 2, we used to do a lot of sort of fancy word problems using distance equals rate times time. So what makes these particular problems different is that 2 parts of a trip will always take place in either the same amount of time or in amounts of time that can be easily compared. So in other words, they show you a relationship between the amounts of time that the two parts of the trip take. So the way that I like to do these, which is a little different than your online homework help might work, is that I take the formula distance equals rate times time. Let me try something here. Distance equals rate times time. And then I solve that equation. Rat. Hold on. Whenever I try to write on my presentation, a lot of times I end up losing my mouse, and it's very awkward because I can't, oh, here we go. Okay. All right, I've got my mouse back. Now I need the pen. All right. All I wanted to show you was that I'm solving this equation for t by dividing both sides by r. So that's how I get t equals d divided by r. Okay. So I'll show you in just a second how I'm going to use that. All right. So I think the thing to do here probably is to show you the first problem. A fisherman on Pearl River rows 9 miles downstream in the same amount of time, there's those words, that he rows 3 miles upstream. And we're going to go over all this vocabulary in case you're not up on your boating lingo. If the current is 6 miles per hour, find how long it takes him to cover the 12 miles. All right. So switching over to the tablet. I have summarized the problem here. All right, so here's how I like to do these. I take my formula T equals D divided by R, and I write it across the top of a chart. Okay. Now remember, typically these problems have a trip that takes place in 2 parts. So in this problem, the 2 parts of the trip are downstream and upstream. Okay, downstream means with the current. So the direction that the water is flowing, you're paddling your boat in that same direction. Upstream means against the current. So that's the hard way to do it. So let's fill in the easy parts of this, and then I will help you figure out the rest. So downstream, he goes 9 miles. Upstream, he goes 3 miles. Okay. So at this point, I'm going to define a variable. This is one of those cases where I am not going to name my variable after what's being asked. So what's being asked is how long does it take, how much time does it take to cover the 12 miles? What's easier in this problem is to use R for your variable, and then I'll show you how to figure out the answer. All right, and this is the type of problem I would never expect you to be able to figure out without seeing an example. All right, if you did, I'd be super, super impressed. Let R equal, of all things, the rate of the boat in still water. So if there was no current, okay? All right, so now I'm gonna do something that you might find a little odd, but I always do this in front of a face-to-face class. And I have a lot of fun doing it. All right, so you see I've stopped sharing my screen, and actually for this, I'm gonna have to turn off my background. You're gonna see the background of my messy office. Okay, but it's all for a good cause. All right, it's a little dark in here. It's getting on 5:30 as I record this. Okay, but I think you'll be able to see me. So what I'm going to do is I'm going to simulate the boat. Remember, the current was 6 miles an hour. So just for now, let's pretend that I can paddle the boat 10 miles an hour. Okay, here we go. Getting out of my chair. All right, so let's do downstream first. So this is me paddling in still water, 10 miles an hour. And then the current picks up. What is my speed now? All right, I started out 10 miles an hour, and then the 6 mile an hour current picked up, and now my speed is 16 miles an hour, right? So remember, we're calling the unknown rate in still water, we're calling that R. That means the rate that I can paddle downstream is going to be R plus 6. Okay, so hold on to that. Now I'm going to go back the other way. So here I am paddling 10 miles an hour, and all of a sudden the current picks up coming this way, and now I can only paddle how fast? It would be 4 miles an hour, right? Okay, so my mystery unknown rate was R in still water. So if the current comes at me going 6 miles an hour, that means my rate going upstream will be R minus 6. Okay, so now I have to go back to the tablet. Okay, so the whole point of that little exercise, literally exercise, was to try to convince you that the rate going downstream would be R plus 6, and the rate going downstream upstream would be R minus 6. All right, so now to get an equation out of all this, notice the formula written across the top, T equals D divided by R. I am going to copy those equal signs down. I'm going to copy those division signs down, except I'll write them like that, which means the time spent paddling downstream is 9 over R plus 6. And the time spent paddling upstream is 3 over R minus 6. All right, so I promise you there is an equation in there. So there is one fact in this problem that I haven't used yet. I haven't used the fact that these two trips take place in the same amount of time, which means the time spent going downstream and the time spent going upstream are equal. All right. So let me skip over to a blank page and we will solve that proportion. Let's see, I think it was R over 9. 9 over R plus 6 equals 3 over R minus 6. And again, this is a proportion. So we can cross multiply. And that's going to give us 9 times R minus 6 equals 3 times R plus 6. 9R minus 54 equals 3R plus 18. Let's get our R terms on one side. Let's get our numbers on the other side. And that's going to give us 6R equals 72, which means R equals 12. That kind of sounds like an ending, doesn't it? Well, whenever you're solving a word problem, you would better make sure that you are answering the question that they asked, which in this case is how long does it take to travel the 12 miles? What we figured out is that the rate of the boat in still water is 12 miles per hour, right? So that's not quite what they asked for, but we're almost there. Okay. So remember that the time going downstream was 9 over r plus 6. And now that we know that r is 12, we know that that's 9 over 12 plus 6, which is 9 over 18, which is 1/2, as in a half an hour. Now, at this point, we really do have all the information we need to answer the question. We could answer it now. I'm going to do something that might seem a little overkill. I'm also going to plug the value of r into the time going upstream. There's kind of a check built into this. If you put that, you get 3 over 12 minus 6, which is 3 over 6, which is also 1/2. I wanted to make sure that those times came out the same. All right, so drum roll, grand finale. These 3 dots mean therefore, by the way. The total trip takes 1/2 plus 1/2 equals 1 hour. Woohoo! Such a simple answer for such a complicated problem. All right. Okay, we got one more, and then we'll call it a day for this section. Okay. A marketing manager travels 1,080 miles in a corporate jet and then an additional 240 miles by car. If the car ride takes 1 hour longer than the jet ride, and if the rate of the jet is 6 times the rate of the car, find the time the manager travels by jet and the time she travels by car. This is one of those problems that you have to read probably 6 or 8 times before you get all the information you need. Okay, so one last time. Let me bring you over to the tablet. All right, so I've summarized the problem here. So we'll set it up the same way that we set up the last one. T equals D divided by R. And this time the 2 parts of the trip are the jet ride and the car ride. All right, she traveled 1,080 miles in the jet and 240 miles in the car. All right, so now I need something to write in the R column. Notice on that 3rd line there, it says the rate of the jet is 6 times the rate of the car. So I'm going to use R to stand for one of those rates. I want you to try to guess which one R is going to stand for. Is it going to stand for the jet or the car? What do you think makes more sense? Let R equal the rate of the, I'm going to make it the rate of the car, because then I can very easily write the rate of the jet as 6 times R. Okay. I think this problem is just maybe a little easier than the last one. All right, so now I will bring my symbols down and divide sign down. So the time spent in the jet is 1,080 divided by 6R. The time spent in the car is 240 over R. Okay. Now, one big thing that's different about this problem is that those 2 trips do not take the same amount of time. The car ride takes 1 hour longer. So we need to be very careful how we set up this equation. Okay, so let's make up an answer. Suppose I told you that the jet ride took 5 hours. That would mean that the car ride takes 6 hours. So when you set up your equation, make sure that you make it say the time in the car is equal to the time in the jet plus 1. It's very easy to put that plus 1 on the wrong side of the equation. So this equation should say 240 over r equals 1080 over 6r plus 1. All right, so now we just have to solve that equation and then we will be pretty much good to go. So let me try to find a blank page. All right, here we go on page 12. Gosh, what did that say? 240 over r equals 1080 over 6r plus 1. So this is not a proportion. I can't use cross multiplication on this one. We have to do it like we were doing the ones in the last section. So the LCD would be 6r. So on the left-hand side, what's going to happen is the r's are going to cancel. And you're going to be left with 240 times 6, which is 1,440. On the other side, you're going to distribute your 6r. So that's going to give us 1,080 over 6r times 6r plus 1 times 6r. All right, so these 6r's are going to cancel, and that's going to leave us 1440 equals 1080 plus 6r. We'll subtract 1080 from both sides. Leaves us 360 equals 6r, which means r is 60. But again, that doesn't answer their question. Their question was, how much time does she spend in the jet and in the car? So kind of like in the last problem, we need to plug that value of r into the time expression for the jet and for the car. And that will also show us if those times relate to each other in the right way. So the car time is 240 divided by r. We think r is 60. That would make the time spent in the car 4 hours. And in the jet, the time spent in the jet is 1,080 over 6r. And again, we think r is 60. 1,080 divided by 360 is 3 hours. Woohoo! The car ride did take 1 hour longer than the jet ride. Okay. Believe me, I understand these are not easy problems. This might be the hardest thing we've done yet. Okay. But I promise that there is easier stuff to come. All right. So don't think it's all downhill from here. I promise you it's not. All right, we'll see you next time. Just one more section to go in chapter 7.